For this section, we are going to be looking at what's called periodic functions. Periodic functions are things that repeat with some kind of predictability. So, for example, weather patterns repeat over the course of a year, or in the case that you're seeing here, this heartbeat pattern repeats every certain amount of time, and it's very predictable. This is called periodic. And if we look at the beginning and ending point, maybe we list that as something pretty easily identifiable, like right here, then it repeats itself after we can count 1, 2, 3, 4, 5 units. So this has a period of 5 units. We've also looked at amplitude as one of our vocabulary words. When we're looking at amplitude, what we need to recognize is we've got a maximum value and we've got a minimum value. And the amplitude is half of this distance. So if we look at this pattern, 1, 2, 3, and about a half. So halfway through here would be about this far. Oops, let me write that in a color. That's the halfway line, which means that my amplitude is this distance here. When we talk about periodic functions, we always have to start with the unit circle. We will be referencing everything in terms of radians, so I'll be looking at the blue numbers. Now you can't forget that your y values are sine and your x values are cosine. So what I want you to pay attention to first is what's happening with the y values as we increase over the unit circle. So at 0 radians, y is 0. Then it increases and increases and increases until we get to 1. And we have a maximum here at 1 because eventually now we're decreasing again. And decreasing, decreasing until we have 0. Then our values become negative until we hit this minimum at -1, and then we increase again back up to 0. So one period of this sine function is the amount of time it takes for us to start or end where we started, which is 2 pi radians. So on a sine wave or a sine graph, the period will repeat every 2 pi. Here's a graphic of what that looks like. So at 0 radians, we had a height of 0. And then our heights kept increasing until we hit a maximum. They decreased, which they're not actually showing here, until we hit 0. They continued to decrease until we hit -1. And then they increased again until we came back up to 0. We can plot these on a graph. Here's 0, 0. At pi over 2, we hit a maximum. At pi radians, we came back to 0. At 3 pi over 2, we hit a minimum, and then our graph started over again. So this, from 0 to 2 pi, is one period of this graph. It's also showing here what it would look like on your calculator. We're going to look at the same thing with cosine, only this time we have to remember that cosine is our x values. So notice here, cosine starts at its furthest point. It's the furthest away from the origin here at 0 radians because it's got a value of 1. Cosine then decreases until it hits 0 up here at pi over 2. Then it continues to decrease negatively until we hit the minimum value of -1 down here at pi. Then, as we progress, it's going to increase to a value of 0, and then it will progressively increase again until we get 1 unit. We can look at this as a table and graph as well. Again, 0 radians, we had a maximum of 1, and that's showing up right here. Then we progressively decrease until we hit 0. That occurs right there. Then from pi over 2 to pi, we're going to decrease even further until we get to -1. Then here we'll increase back to 0, and then finally we'll go back to our maximum. So again, with cosine, one period of the graph, if it starts here and ends in the same place, is still 2 pi, because it takes 2 pi radians to get back to where it began. What we need to do now is we need to be able to graph these functions. So we're going to start by graphing the sine of x. Now we know that the period of a sine graph is 2 pi. So what I'm going to have you do is I'm going to have you list out the key coordinates for one period of this graph. We start at 0, we end at 2 pi. Now the key coordinates are going to occur at the halfway point, in this case pi, fourth of the way through, which in this case is pi over 2, and 3/4 of the way through, which is 3 pi over 2. Now something that we need to remember about the sine function. At 0 radians, it is 0 units above the x-axis. At pi over 2, we have a maximum, so that's a fourth of the way through the period, we're at a maximum. Halfway through the period, we're back at 0. 3/4 of the way through, we're at a minimum. And then at the end of the period, we're back where we started. What I have done here is I have listed out your x and y coordinates to plot points. So we've got a point here at 0, 0. At pi over 2, 1, at pi 0, at 3 pi over 2, -1, and at 2 pi 0. There's one period of my graph. When you graph this, please remember that these graphs are curvy. We should not have points on sine graphs. You should also notice that I've got a big blank back here. Get in the habit of repeating your graph on the negative side. So if I move backwards, I should be at -pi over 2, -1, -pi 0, -3 pi over 2, +1, -2 pi 0. And there's my graph. One thing that we have not talked too much about was amplitude. If the circle that I'm using is not a unit circle, but instead has a radius of 2, then my maximum won't be 1 anymore. My maximum will be 2. So this 2 is the amplitude of the function. When we are graphing this, you'll actually start the exact same way. With all of this information here, the beginning and end of the period, a fourth of the way, halfway, and 3/4 of the way through. Then you'll have to memorize this pattern of 0, 1, 0, -1, 0. With your amplitude, you'll just double that. So 2 times 0 is 0, 2 times 1 is 2, 2 times 0 is 0, 2 times -1 is -2, 2 times 0 is 0. So now, when I graph 2 sine of x, it looks like this. And if I move backwards, it looks like that. So notice we're reaching maximums in the same point, minimums in the same point, and zeros in the same point. The only thing that's different is we've stretched vertically. My center line in this case is the x-axis, and my amplitude has moved 2 units above and 2 units below. The last thing that we're going to graph is sine of 2x. What I've shown you here is simply sine of x. But I want you to be able to compare sine of x to sine of 2x. This 2 changes the period of this graph. So what we have to do now to calculate the period is we need to take 2 pi divided by that value. So in this case, the period of the graph is pi units. I'm going to go through the same process I did before. I'm going to list out the beginning and end of my period, halfway between, a fourth of the way, and 3/4 of the way. The sine graph has the same pattern. 0, 1, 0, -1, 0. So I'm still showing x and y coordinates. But notice now, my maximum is occurring a little bit sooner. And this graph has completed one cycle in a much shorter span of time. We'll proceed to finish this graph on the positive side, and we can do the same on the negative side. So when you change the period of a graph, you're squishing it together. We'll now take a look at the cosine graph. I'm going to start just by graphing y equals cosine of x, and because it's just a plain cosine of x, the period of this graph is 2 pi. So I list out 0 to 2 pi, halfway, a fourth of the way, 3/4 of the way. But now I have to remember that on my cosine function, I start at my maximum. I start the furthest away possible, which is 1. Then as I hit 90 degrees, I'm at 0, then -1, 0, back to +1. So this is the pattern for cosine. And I can graph these points as well. And I should be able to graph them backwards. And notice that I'm still making these graphs curvy, not pointed. For the next graph, I'm going to change only the amplitude. So for this one, I'll multiply each of my y coordinates by 1/2. And notice this graph gets smushed vertically so that it would almost become a flat line. For our final graph, we'll graph y equals cosine of 1/2 x. So again, for this one, we need to look at the period of the graph. And we have to say, okay, well, I need to take 2 pi divided by 1/2, because that's the number right here, attached to x. So that will be the same as 2 pi times 2/1, or 4 pi. So in this case, the period of the graph is 4 pi. I list out my beginning and end. I list halfway through, a fourth of the way through, and 3/4 of the way through. Then, because it's a cosine graph, I follow the pattern of cosine. 1, 0, -1, 0, 1. So now at 0, we're still at 1. But at pi, we're at 0. And at 2 pi, we're at -1. I don't even have part on this graph to show 3 pi and 4 pi. But I can go backwards to here and then to here. So notice that if the period is 4 pi, it stretches out my graph horizontally so that I don't get as many cycles. I hope based on this that you're able to do some graphing when we get to class next time.